So we'll come back and we'll run through like section 7.1, 7.2, and 7.3. But we're going to do like the application problems. So those are generally going to be word problems where you set up your own equations and solve for the variables. And so just as another reminder, if you forgot about the yellow sheet or if you had looked at the yellow sheet and thought I couldn't do those problems, then please make an effort to complete the 8 questions on the yellow sheet so that you know you're comfortable solving different types of systems. So we're going to talk about multivariable linear systems today. Basically what we mean by that are 3-variable systems. So I've got one example of a 3-variable system to start. Now those of you who got to number 7 and 8 and were able to complete number 7 and 8, you had a good review of maybe how you were taught to approach a 3-variable system. So if you have a different method that you use, just know that we should get the same answers, and we just want to make sure that we can all like solve the system and show our work so that we could potentially earn partial credit if we make a mistake. But what I'll put out there for everybody is it's super helpful to me when I'm grading your stuff if you use some kind of organizational system. So I like to use a system where I label my 3 equations. What you label them doesn't really matter. I use labels row 1, row 2, row 3. Some teachers, I think, use ABC. Some teachers might use 1, 2, 3. You can use any system that you want. But this will be really great because then you can do things with those equations and you can label the things that you're doing. And then if you can't get the right answer, Noah can bring his work up to me and I can see, oh, he multiplied row 1 by 2, and I can double check his math. If he doesn't write that down, I have a really hard time following the work, and so you may not get partial credit because I just don't know, I can't tell what you did. So please be organized. I like to use row 1, row 2, row 3 because we're going to see that notation in chapter 8 with matrices, and we're going to do something called row echelon form, so it just kind of gets us comfortable with rows. Okay, so next thing I would do with the 3-variable system is look over my equations. And I always try to work smarter, not harder, if possible. And think about, like, what variable would be a good variable to eliminate? X, Z. Anybody want to argue one over the other?
Z.
Why Z? There's already a plus Z and a minus Z. So won't Z cancel without any work at all in row 1 and row 3? Yeah, I like that too. So let's do that. Now, those people who said X, are they wrong? No, you could eliminate X's. That's fine. And you can even do Y's because each of them has a coefficient of 1. They're really easy to work with. But I would argue if we want to do the least amount of work possible, we're probably going to eliminate the Z's. Okay, so let's copy row 1 and row 3. We don't have to do any kind of multiplying. We just copy the equations. Like Jayla says, they're set up to eliminate right now. So remember that when you stack those 2 equations, the operation down is plus. That's why we get opposites. Then opposites add to 0. So I'm going to get 3x plus 5y equals 0. And I'm going to go ahead and label that row 4. That's a new equation. That's going to be my row 4. Okay, so I've created one equation that now has 2 variables, but I'm not able to solve for one of those variables until I have 2 equations and 2 variables. So I eliminated Z once, now I have to eliminate Z again. This time, what 2 rows would you like to use to eliminate Z? Row 1 and 2. What will I have to do to row 1? Multiply by 3. So let's do row 1, row 2. And we're going to multiply row 1 by 3. Now, could you have done row 2, row 3? Sure. Then you would multiply row 3 by negative 3, which would be fine. Some of you might have flashbacks to Algebra 2. Remember, it's really important that you remember to distribute the 3 to all terms. 6x plus 12y plus 3z equals 3. I can't tell you how many of my Algebra 2 students leave off that 3 times 1 and they just write 1. That's a bummer. Copy row 2, x minus 2y minus 3z equals 2. And then remember, we're always getting opposites, so our operation there is adds. I always say stack and add. So I get 7x plus 10y equals 5. I'm going to call that row 5. So what I did just there is create a 2-variable system with 2 equations. And now that looks like problems like 1 through 4 on the yellow sheet that you reviewed today. And everybody should come into room A08 for pre-calculus, being able to solve the 2-variable system. So I'm going to solve the 2-variable system for row 4 and row 5. When I look at those two, what variable do you want to eliminate? Y will have to multiply row 4 by negative 2. So that's going to be negative 6 minus 10y equals 0. Oops, 6x. And 7y plus 10y equals 5. Oops. Sorry, I'm squeezing it in over there. See if I can slide those over. Just have to put it down below. 5. Stack and add, that's x equals 5. So that worked out pretty nicely for me. And then 2-variable system. Once you have one variable, plug it back in to find the other variable. I could use row 4 or row 5. I should get the same answer in both of those equations. I'm probably going to choose row 4 because it has smaller numbers. So I'm going to do row 4 is 3 times 5 plus 5y equals 0. So that's 5y equals negative 15 and y equals negative 3. Are we okay with what I'm doing? Anybody got any questions for me? Okay, so once you finish solving the 2-variable system you created, now you can find your 3rd variable by plugging those 2 into one of the original equations, right? What's the variable we have left to solve for? Z. So I usually try to pick my equation wisely. When I look at row 1, row 2, row 3, I'm going to go ahead and plug into row 1. It's got small coefficients, and also z is positive 1, so then when I move the other things to the other side, I'll have z right away. So I'll move this up here in just a minute. I'm going to do row 1. I'm going to do 2 times 5 plus 4 times negative 3 plus z equals 1. So I'm plugging in my x and my y value. Yes, ma'am.
Why would you plug it into row 3?
You could plug it into row 3. I don't want to plug it into row 3 only because then I have the negative z right there.
Okay.
So I'm just like saying, oh, well, then I'll just subtract those things to the other side. And it doesn't matter. So if you want to do row 3 in your notes, you can. 10 minus 12 plus z equals 1. That's negative 2 plus z equals 1, so z equals 3. You should get the same answer in the 3rd equation. Now, how do you represent answers to a 3-variable system? Ordered triple. And just like how we like to be organized, we're going to go ahead and put those in alphabetical order, X, Y, Z. So we're going to do 5, negative 3, 3. So if you want some extra practice, you know, you've got your homework assignment tonight, then you've also got those two problems on the yellow sheet. So if you didn't do 7 and 8, you can go back and try those. One of them does have fraction answers, but you should feel comfortable working with fractions. Like you can plug a fraction back in and get another answer. So don't be alarmed if you get a fraction. All right, questions or concerns? Okay. Now, I'm going to show you one that is similar but different than what we saw in Algebra 2. So it's another three-variable system. I'll give you a chance to jot this down. The first equation is missing a y. Okay, so I would start this one off in the same manner. So I would go ahead and label my rows. Row 1, row 2, row 3. You know, surveying my system, I notice row 1 is already in 2 variables, right? So I want to use the other 2 rows to eliminate the same variable that's missing in row 1. So I'm going to eliminate y. Then I only have to do that job once this time. So I'm going to do row 2 and row 3. What will I have to do to one of those rows? Multiply by -1. It doesn't matter which one you choose. So I'm just going to do it to row 2. And stack and add my equation. So I get 3x plus 6z equals 15. I'm going to call that row 4. So now I can use row 4 and row 1 as my 2 variable system. And looking those over, what variable would you guys like to eliminate? X or Z? Doesn't matter, but like we would just have to pick one in the beginning, right? So we would say, oh, okay, I'm going to eliminate X. So maybe you have to multiply row 1 by a -3. But like Dylan is saying, well, he noticed that the same thing is true if you're trying to eliminate y. You would multiply by -3. So what happens is everything eliminates, right? So we get something like 0 equals 0. What did that mean back in Algebra 2? Infinitely many solutions. What's the other option that you sometimes get? No solution. How does it look when it's no solution? 0 equals a number that's not 0, right? Like 0 equals 5. I feel really bad about that. I'd rather have $5 than $0, so they're not equal. So when you get an untrue statement at the end, 0 equals something else, that's no solution, and you would stop. When you get a true statement like 0 equals 0, or if you're doing substitution, you can get something like 6 equals 6. That's true. Then that's infinitely many solutions. Last year in Algebra 2, you would stop. This year, we're going to pin down those infinitely many solutions. Okay? So what's happening with a 3-variable system is now we have x, y, z. We're working in space. So we have the x, y plane, and then we have a z plane that goes up and down. So we have 3-dimensional space. And when we have represented these equations, we're talking about like planes intersecting each other. Okay, so where the planes will intersect or lines will intersect. And what happens here is we have planes that are intersecting. When you get infinitely many solutions, they're intersecting and they're forming a line. So there's like all these many points, infinitely many points on this line where the two planes are intersecting, and we want to know, okay, it's not like all real numbers. Not every ordered triple works. We want to pin down what are those specific ordered triples. So what mathematicians are going to do is they're going to pick a variable in the two variable system. So I have x or z, and they're going to let one of the variables equal something else, a placeholder, which we're going to call a. So I'm going to say, after I get infinitely many solutions, let z equal a. Now you sound like a real mathematician when you use the word let. Let z equals a. Now, could you have said let x equal a?
Yeah.
Yes, totally fine. So it's not like when you're doing your homework, you have to choose one or the other. I will say that the majority of the time, the back of the book lets z equal a. So if you're trying to check your answer in the back of the book tonight, you need to let z equal a for the most part. There's one problem, I think, where it doesn't. But on your quizzes or tests, whatever, you can use any one to let it equal a. Okay, so it could be let y equal a, let z equal a, let x equal a. Okay, so that means in the ordered triple, z is a. Now, if I knew z was a, it's just like saying z is 5. If you knew z was 5, how would you get x? You plug it back in and solve for x. So if z is equal to a, let's plug it back in and solve for x. So the rule doesn't change just because it's not a number. So I think I'm going to plug it into, I think it's row 1. What does row 1 look like? Yeah, x plus 2z equals 5. So I'll move it back up here in just a second. I'm going to do x plus 2 times whatever z is, which we said was a, equals 5. So let z equal a, then to solve for x, x plus 2a equals 5. X is equal to 5 minus 2a. So it's how x is related to z in terms of a. And then now that we have x and z, how would we find y? Plug it back into one of the original equations. So I think I'm probably going to plug it into row 2, just because it has some smaller values. So I'll move it back up here in just a second. Row 2 is going to be 3 times x, which is 5 minus 2a, minus y minus z, which is a, equals 1. Only variable that should be still a letter is the one that you're trying to find. So we're trying to find y. So I should only see y's in here. I shouldn't see x's and z's anymore. I want everything in terms of a. And so then I simplify 15 minus 6a minus y minus a equals 1. That's 15 minus 7a minus y equals 1. And since I'm trying to solve for y, I'm just going to go ahead and add y to both sides, and then subtract this 1 over to the other side. That way I get 14 minus 7a equals y. So now we're pinning down the solutions. Infinitely many solutions that fit this relationship. 5 minus 2a, 14 minus 7a. So if you wanted an example of an ordered triple that works, you could let a equal some number. Let's say a is equal to 1. If A were equal to 1, then 14 minus 7 would be 7, and 5 minus 2 would be 3. So the ordered triple 371 should work in all three equations. Or I could let A equal 0. Then that would be 14 minus 0, which is 14, and 5 minus 0, which is 5. So those two numbers should work in all equations. You don't have to list these solutions. This is the one that I want in terms of A. Questions? Okay. Last example is going to follow this pattern. You're going to have to let a variable equal A. So this is where we need to get comfortable as pre-calculus students. But it's called a non-square system. So I just want you to be prepared when you see something like this. Non-square system is referring to the fact that the number of variables that you're trying to solve for does not equal the number of equations. So like if you have two variables, to solve for them, generally you need two equations in two variables. If you have three variables to solve for the order triple, you generally need three equations. So if you have a non-square system, you're not going to be able to pin down the exact point. You're going to use our let a variable equal A. This says equations. This is my apostrophe. I know it looks funny. Okay, so I would treat this one the same. Right now I have way too many variables, so I'm going to reduce it to a two-variable equation. What variable do you want to eliminate? Try x. So we're going to do negative 5 times row 1 and add it with row 2. So it's going to be negative 5x plus 15y minus 10z equals negative 90. 5x minus 13y plus 10z equals 80. Stack and add. Oh, did I put 113? I meant 13. My apologies. So that's what? 2y plus 2z equals negative 10? I'm going to call that row 3. Well, I'm kind of stuck. I eliminated x with row 1 and row 2, but I can't eliminate x again. So I can only get down to one two-variable equation. So the best I can do is say, let z equal a. I have a z here. I could say let y equal a, couldn't I? Let z equal a. In my order triple, oops, z is a. Now I'll solve for the other two. 2y, this is in row 3, 2y plus 2a equals negative 10. So 2y equals negative 10 minus 2a. And y equals negative 5 minus a. Oops, that's y. And then I can plug that into either row 1 or row 2. It doesn't matter which one, and solve for x. I'm going to choose row 1. X minus 3 times negative 5 minus a plus 2a is equal to 18. Distribute, combine like terms, get x all by itself. So it's going to be x plus 15, x plus 15 plus 3a plus 2a equals 18. So if I subtract 15, I'll get 3, and if I subtract the 5a, I'll get minus 5a. And that's my solution. So in a non-square system, you usually wouldn't be able to pin it down. So you're just going to represent like these values will work in these two equations. We can't say for sure what x, y, and z are definitively. Okay. What questions do you have for me? Yes, Hannah. Uh-huh.
Solve for y and plug it back in.
Arrow 3? I could solve for y, but then it would be in terms of z. So if you're going to be solving for a variable, it's going to be in terms of another variable. Mathematicians are going to put a placeholder. Like I had the question last hour, why do we have to let z equal a? Why can't it just equal z? Because we want to say it's not z, it is some number, and that number is a. It is kind of redundant, but we just started let z equal a. So that whole like statement, let this thing equal this, that'll come back to us too when we do proofs. So it'll be helpful for you to just know it's just substituting in. It's just a placeholder. But that's why you don't have two equations in two variables. So you don't have enough to solve for x or y or z. Anything else? Okay, you do have a homework assignment, and did I hand out your gold sheet, or you need a gold sheet? You need a gold sheet, okay. So you do have a homework assignment. Now look here on the screen, this is the same homework assignment. There's not that many required problems. So some of us may do the required problems in our yellow sheet we didn't finish. Some of us may do the required problems and maybe a few extra ones, just for fun. Page 474 and page 484, those are going to be two variable systems, and there's going to be some of those nonlinear ones on there. So it is good for you to look at. If you don't look at it tonight, you can always look at it another night. So we've got just under 15 minutes. I want everybody working on their homework assignment. I am going to pass out your midterms so that you can look them over. You guys did a really nice job on those. And then I will also be collecting the midterms, so don't pack it away.